All right, so for you ditchers, I'm going to record for you, all right? That's right. All right, so this is number 2 on the pre-assessment. Just redoing this real quick. The question is, find the length of the arc on a circle of radius 25 feet intercepted by a 85-degree central angle. Express the arc length in terms of pi, then round your answer to 2 decimal places. So the whole circle is, the circumference is this right here, pi, 2 pi r. And what you're doing is you're just getting the 85 over 360 because there's 360 degrees in a circle. You only need to get 85 of that. So this is the proportion, or this is the portion that you need, and you're getting this other circumference. So if you multiply this out, this equals 37.06. All right. Number 3. If you look at this right here, you have the point -2 and +5. 1, 2, 3, 4, 5. So this is -2, +5, -2, +5. You want to get the hypotenuse of this. So the hypotenuse is you get 2 squared plus 5 squared. And this is 4 plus 25. That equals c squared. So c squared is equal to 29. C is equal to the square root of 29. So this hypotenuse is radical 29. So if you want to get the 6 trig functions, they are the sine of theta this is theta right here, opposite over hypotenuse, which is 5 over radical 29. The cosine of theta is equal to -2 over radical 29. And the tangent of theta is equal to 5 over -2, which is -5 over 2. The cosecant, which is the reciprocal of sine, is radical 29 over 5. The cosine, sorry, the secant, my bad. The secant of theta is equal to radical 29 over 2 to negative. And then the cotangent, you're just getting the reciprocal of these, so it'll be -2 over 5. So that is number 3. All right. Number 4, A is equal to the sine of pi over 6 cosine pi over 3 minus sine pi over 2. The sine of pi over 6 is 1 over 2. So again? It's cosecant. Cosecant pi over, thank you. Sorry, thank you. So cosecant, so sine of pi over 6 is 1/2. The cosecant of pi over 3, if you look at the unit circle pi over 3 is the reciprocal of sine. So pi over 3 is the cosecant of pi over 3. So sine of pi over 3 is radical 3 over 2, right? So the cosecant is a reciprocal of that, which is 2 over radical 3. All right. I will rationalize it later on, but for now, let's just leave it like this. And then minus the sine of pi over 2, which is 1. Okay. And so 1 times 2 is 2, and it is 2 over radical 3 minus 1. Let's rationalize the denominator first before we move on. So it'll be 2 radical 3 over radical 3 times radical 3 is 6. 6 times 2 is, sorry, radical 3 times radical 3 is radical 9. Radical 9 is 3. 3 times 2 is 6 minus 1. And so we get the common denominator. It's 2 radical 3. And we'll put it over 6 minus 6. You could leave it leave it like this, that's fine. Okay. The cosine of letter B the cosine of 12 pi over 4 is equivalent to the cosine of 3 pi. If you look at the unit circle, the cosine, the x value of pi is -1. Yeah.
For A, can't you end up making it just radical 3 minus 3 over 3?
Radical 3 over 3.
Or radical
Yeah,
3 minus 3
yeah, you could simplify it. Yes, you can. So this is radical 3 minus 3 over 3. Yes, you could simplify that.
That sounds right.
Cool. That is correct. That's probably the better answer than what I put. Cool. All right, number 5. Number 5 is graph y is equal to 3 sine 2x. Remember, the amplitude is 3. All right, and the sine 2x. So the period is 2 pi over 2, which is pi. And remember, when you graph this, first of all, you want, since the pi is 1 full period, you want to divide this into 4. So it'll be pi over 4, pi over 2, 3 pi over 4. So you want to divide that up into 4 pieces. And then you want to go up to 3. So it starts at 0, 0. At pi over 4, it goes to 3. Goes back down to 0 at pi over 2. And then at -3, then back up at pi. Okay, so remember to divide by 4, right? Your period by 4, and then you have the 4 different markers in a wave. All right. Number 6 is the cosecant. Sorry, the secant. Y is equal to 3 secant x plus pi. Okay. What I would do is maybe draw the cosine function first. Y is equal to 3 cosine x, and then we'll shift the wave pi after we're done with this. So if we draw the cosine, this is 3 and this is -3, and the period is 2 pi. So this is pi over 2, right? And this is 3 pi over 3 pi over 2, yeah. And so when we graph this, it's right here, right? Pi over 2 goes to 0. At pi goes to -3. At 3 pi over 2 goes to 0. And then that full period is right here. And you may want to graph this a little bit longer, because that'll help out. Okay. So this is the cosine function. And the reason why we graph the cosine function is because the secant function is like its opposite. So what we're going to do is whenever it hits 0, we're going to draw asymptotes. All right. And then what we're going to do is with the red, we're going to put parabolas where the vertices are. I hope that you guys practice this. Okay. And now that it's shifted -pi times, you're just moving it over 1 time. So in blue, so the real graphs are here, right? And then they are here, 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 so on and so forth. So wherever it's blue, that is your secant function. Okay? Because you shifted it pi times to the left. All right? I would like for you to show all this, like the wave, how you shifted, all that good stuff, okay? So I would like for you to shift. And I mean, you could do the table of values as well, but I think this is a little bit faster than doing, a table. Right? All right, number 7, it's, find the tangent of the cosine, the inverse cosine of -1/2. Okay, the cosine of -1/2. Where's the x value at -1/2? So -1/2 would be either quadrant. So it would be 4 pi over. Right, it would be, this is 4 pi over 3. Right, negative 1/2, or it could be, 2 pi over 3. So this could be either or. So this could be 2 pi over 3. So you get the tangent of 2 pi over 3, and you get the tangent of 4 pi over 3. Because that's where cosine is -1/2. Okay, so remember that at 2 pi over 3, the it's at -1/2 and comma radical 3/2. And then the tangent of 4 pi over 3 is -1/2 comma negative radical 3/2. Okay. So if you do this, so it would be the tangent of 2 pi over 3. So tangent is equal to sine over cosine. So it'll be radical 3/2 all over -1/2. If you divide this out, this is equal to negative radical 3. Here, we're doing this right here. It would be radical 3/2 over negative radical 3/2 over -1/2. This is equal to positive radical 3. So both answers are correct, right? Well, yeah,
I have a question. I did it another way and I got the same answer, but I didn't get both radical 3s. So what I did is I plugged in cosine -1. I plugged that into the calculator.
Mhm.
And then it gave me tan 120. And I just went to 120 and then I plugged that in and it would be -1/2. And square root 3/2, and then I got,
decimal of radical 3.
yeah, I got negative radical 3.
Okay, yeah, that should be right. That's good. Because all they're asking for, if they give you a range, maybe if I give you a range, I might just do this right here. I should have given you a range, like from 0 to pi. So I should have given you a range of some sort. Cool. But either answer is fine. All right, so find tangent in, if cosine theta is negative radical 3/2 and the sine is less than 0. So the sine is less than 0, is negative on quadrants 3 and 4, right? And it is negative radical 3/2 cosine only on 7 pi over 6, right? So 7 pi over 6, that is where cosine is cosine of theta is equal to negative radical 3/2. So at cosine radical negative 3/2, this is theta is equal to 7 pi over 6. So once you find the theta, you can find the tan now of theta, which is 7 pi over 6. And the coordinates of this are negative radical 3/2 comma -1/2. So it's sine over cosine, which is -1/2, negative radical 3/2. You can pretty much cancel out the 2's and then cancel out the negatives. So it's pretty much just 1 over radical 3. which rationalize it'll be radical 3 over 3. Okay. And then letter 8B is draw a triangle where you have the tangent is 4 over 3 and the cosine is less than 0. So if the cosine is less than 0, it's either quadrants. You guys, come on. Like, I'm trying to do this here, and you guys are just messing around. Come on. So we have tangent of -4 over 3, which and then cosine is less than 0, so it has to be this way right here. So it's either going to be the cosine, then it either has to be quadrants 2 or 3, because that's where x is 0. Okay, and we have, let's see here, tangent is 4 over 3, so the opposite. So I think it has to be in quadrant 2, because we have the opposite, which is 4, and the adjacent, which is 3. This is -3. So that means that this is the hypotenuse is 5 if we do the Pythagorean theorem. Okay. So now we have to find the secant and we have to find the secant and cosecant. Well, let's find the sine of theta is equal to 4 over 5. The cosine of theta is equal to -3 over 5. The tangent of theta, as we already mentioned, is -4 over 3. So that means that the cosecant of theta is 5 over 4, and the secant of theta is equal to -5 over 3. And those are your two answers, 5 over 4 and -5 over 3. All right. Yeah.
How do we know that it's in the second or third one again? Like, what tells you that which quadrant?
If you were listening, it's just, no, it's kidding. What you call it? It's because
X equals 0.
Yeah. Cosine, so the cosine is less than 0. That means that wherever cosine is negative, right? But if we chose a number here, and if it was tangent would be positive, right? Because the negative divided by negative, both coordinates right here would be
okay.
y, x over y would be positive, so that's why it has to be in quadrant 2.
All right. Thank you.
All right. Cool. Yeah. A lot of thinking here, but it's not too hard. It's just a lot of thinking and putting together. Okay. So Jack climbs on a horse that is 12 feet from the center of the merry-go-round. All right, so here is the merry-go-round, here is the 12 feet, that's the radius. All right, the merry-go-round makes 3 1/4 rotations per minute. So 3 1/4 rotations for 1 minute. So determine the angular velocity in radians per second. So remember, let's turn the rotations into radians. 1 rotation is how many radians? 2 pi, right? And then we got the radians down, so that's done. Then how many seconds? So 1 minute is how many seconds? 60 seconds, right? Okay, so we have the units that we want. So it'll be 3.25 times 2 pi divided by 60. Let's just multiply out 2 pi. So it'll be 6.28 times 3.25 divided by 60. That is 0.34 radians per second. Okay, so that is your angular speed right there. Now we have the radius of 12 feet, and we want to, so we have to multiply the angular speed times the radius to get the linear speed. So multiply this by 12 feet. And remember, it's 12 feet over 1 radian. So cancel this out here. So it would be 0.34 times 12. It would be 4.082 feet for 1 second. And that is your answer. All right,